This lecture deals with the normal distribution. Key concepts include theoretical versus empirical distributions, characteristics of the normal distribution, z-scores, and the standard normal distribution and standard normal table. We begin by talking about the difference between a theoretical and empirical distribution. An empirical distribution is one that's based on real data. For example, something like the distribution of income for some group of people at a particular point in time and place. While a theoretical distribution is one that's based on theory, not data. Theoretical distributions are of great significance for inferential statistics, and in this lecture we're going to focus on one particular theoretical distribution, the normal distribution. The normal distribution is a bell-shaped, symmetrical distribution, centered around its mean. Figure 1 shows the distribution of the normal distribution. Notice that it has several different characteristics. First of all, it's bell-shaped, meaning that most of its area is at the middle, and an increasing smaller percentage of the area is out towards the tails. It's also centered around the value of its mean, median, and mode, which are directly in the middle of the distribution. And it's symmetrical, meaning that the left side of the distribution is equal to the right side of the distribution. Although the normal curve is a theoretical distribution, it well approximates many theoretical distributions. So for example, variables like IQ or height follow a normal or approximately normal distribution. The next slide shows the distribution of the variable word sum from the General Social Survey, which is a measure of the number of correct words that people got on a vocabulary test. Take a look at the distribution. Notice that it looks approximately normal. You can see that the mean is about 6, but there are some people who got fewer than average words correct. For example, 4, 2, or 0 words. And some people got more than the average correct, 8 or 10 words. The term normal curve doesn't refer to a single distribution. In fact, there are many normal curves, and the shape of the normal curve varies according to two parameters, its mean and its standard deviation. The following plot illustrates this concept. It shows curves that have the same mean, in this case 66.5, and a different standard deviation. Notice that the curve represented by the dotted line, or the dashed line, has a standard deviation of 4.1, while the curve represented by the solid line has a standard deviation of 2.7. Notice that the dashed line curve has a much higher spread or variation around the value of the mean, but a much lower peak, whereas the curve with the smaller standard deviation has a much higher peak and a narrower distribution of cases around the mean. These two curves have the same standard deviation, 2.7, but they have different means. So you can see that the curve on the left has a mean of 56, while the curve on the right has a mean of 66.5. The average, or mean, basically dictates the location of the curve on the horizontal axis. And as we saw earlier, the standard deviation determines how much of the area is around the mean. Regardless of which normal distribution we're talking about, all normal distributions have the following property. They have a constant proportion of area under the curve between the mean and any given distance from the mean. That is, when the distance is measured in standard deviation units. So let's take a look at some of the areas under the curve at different distances from the middle. We see that about 99% of the area, a little over, is within 3 standard deviations above and below the mean. Approximately 95% of the area is within 2 standard deviations of the mean. And then another 68% of the area is within 1 standard deviation of the mean. The entire area under the normal curve is 1, or 100%. And since it's a symmetrical curve, half the distribution is above the mean, and the other half is below the mean. Put differently, 0.5, or 50% of the distribution is to the left of the mean, and the other 50% is to the right of the mean. So how do we use the normal distribution? Well, since the distance from the mean to any point on the normal curve is fixed, we can determine what proportion of the distribution falls between the mean and any given score, as long as we have a variable that's normally distributed, or at least approximately normally distributed. And that requires that we express the distance from the mean to any given score in terms of standard deviation units, or z-scores. So z-scores measures the distance from the score to the mean in a metric that uses standard deviations. A large z-score means a further distance from the mean, while a smaller z-score means a shorter distance. And we can transform any raw score into a z-score using the following formula. The formula here tells us that z, which measures the distance from the mean in standard deviation units to some raw score, is equal to that raw score, let's say for the variable y, minus its mean divided by its standard deviation. So why use this formula? Well, recall when we were calculating the variance that when we took the mean and subtracted from each score of a distribution, it summed to 0. Therefore, if we took those values, and divided them by the total number of cases, we'd also get 0, implying that the new mean is equal to 0. It turns out that when we divide each score by the standard deviation, that makes the new standard deviation equal to 1. And so, the z-score transformation formula basically takes raw scores and changes them so they have a mean of 0 and a standard deviation of 1. And z-scores basically tell us the distance from the middle, or 0, in unit increments of standard deviations. Positive z-scores indicate that the distance is above the mean, while negative z-scores indicate that the distance is below the mean. And I'll note that most of the areas under the normal curve are within 4 standard deviations above and below the mean. Now, when we take the normal distribution and represent it in terms of z-scores, we have a special name for the resulting normal distribution. We call it the standard normal distribution. The standard normal distribution, or standard normal curve, has a mean of 0 and a standard deviation of 1. And we can use something that statisticians have developed called a standard normal table to find the associated areas for any scores on the standard normal distribution. So the standard normal distribution basically just shows the corresponding areas and z-scores. And it's organized into 3 columns. Here's an example of a standard normal table. Column A shows the different z-scores, while column B shows the area between the mean and the z-score, and column C shows the area beyond the z-score. Note that if you took the area in column B and added it to column C, it would always sum to 0.5. Let's look at a given z-score and try to figure out what areas correspond to it. So let's say that we use a z-score of 0.25. We'll notice that the area between the mean and the z-score is 0.987, or expressed as a percent, 9.8% roughly. The area beyond the z-score is 0.04013, or 40.13% of the area. Also know that only positive z-scores are listed on the table. But because the normal distribution is symmetrical, areas corresponding to positive z-scores are the same as areas corresponding to negative z-scores. In other words, if you found a negative z-score, you wouldn't find it listed in the table, but you can just use the positive z-score and you would get the same area. Let's look at some examples of using the normal distribution for actual calculations. Let's return to our data about the number of words that people got correct on a vocab test. And suppose that we wanted to know how many people got between the mean and 8 words correct. Well, recall that our distribution of correct words is approximately normal, with a mean of approximately 6, specifically 5.92, and a standard deviation that's just above 2, or 2.05. So in order to figure out how many people got between the mean and 8 words correct, we would take our raw score, in this case 8, and we would transform it into a z-score using the formula. Then we'd find the area under the normal curve corresponding to that z-score. It's always helpful to start with a diagram. And so this diagram here illustrates the distribution of the variable word sum. And we can see that we're looking for an area that's corresponding to a positive z-score, because 8 is greater than the mean. Recall that the mean is 5.92. And so we have to take 8 and we have to turn it into a z-score. We're going to use the following formula. And the formula tells us to take 8, our raw score, subtract the mean, 5.92, and divide it by the standard deviation, 2.05. When we do the arithmetic, we get a value of 1.01, and that's our z-score. And our z-score tells us that 8 is over 1 standard deviation above the mean. Now we have to figure out what area corresponds to a z-score of 1.01. And we have to do that by figuring out which area in the table to use. And so we need to look up 1.01 in column A and figure out which column we should use. And so if we look up that z-score, 1.01, we have the choice between 2 columns, column B or column C. Which one is appropriate? Well, looking at our diagram, we can see that we're looking for an area between the mean, 0, and the z-score, 1.01. And so we use column B in the table. The column B value that corresponds to our z-score, 1.01, is 0.3438, or expressed as a percent, that's 34.38%. So that's the answer to our question. 34.38% of people got between the mean and 8 words correct on the vocab test. Let's move on to example 2, in which we're going to convert a negative z-score into a proportion. Suppose now that we wanted to know what percent of students got between 4 and the mean words correct. And so, because 4 is below the mean, 5.92, we're looking for an area below the mean this time. In order to find that area, we have to take 4 and we have to turn it into a z-score, and we use the formula. So this time, instead of using 8 as our raw score, we're going to use 4 as our raw score. And we're going to take 4, subtract the mean, 5.92, and divide it by the standard deviation, 2.05. And when we do the arithmetic, we get a value of negative 0.94, which tells us that 4 is just under 1 standard deviation below the mean. Now we have to look up 0.94 in the standard normal table and find the column corresponding to the appropriate area. But before we do that, we need to figure out 2 things. First, which column do we use? And second, how do we deal with negative z-scores? First of all, negative z-scores aren't listed in the table, and that's because the normal distribution is symmetrical. So areas below the mean are proportional to those above the mean. So we'll just use the positive z-score instead of the negative z-score. In other words, we'll use positive 0.94, and we'll get the same answer. Now we have to figure out whether we should use column B or column C. Looking at our diagram, we can see that we're looking for an area between the mean, 0, and the z-score, negative 0.94. And so we want column B, the area between the mean and the z-score. And so if we find the appropriate z-score and column corresponding to that z-score, we see that the value that we want is 0.3264. Expressed as a percent, that's 32.64%. In other words, we can say that 32.64% of people got between 4 and the mean words correct. Now suppose that we wanted to find a negative and a positive area. For example, let's suppose that we wanted to know what percent of people scored between 4 and 8 correct words. This time we're looking for both a negative and a positive area above and below the mean respectively. So how do we do this? Well, we're going to take each of those values, 4 and 8, and turn them into z-scores, which we did in a previous example, find the areas corresponding to both of them, and we're going to add them together. And so we saw that the areas for 4 and 8 respectively were 34.38 and 32.64, and when we add those two together, we get 67.02. And so that means that approximately 67% of people got between 4 and 8 correct words. Our next example, we're going to find an area that's above the z-score for both a negative and a positive z-score. So suppose we wanted to know what proportion of people got 8 or more words correct or 4 or fewer words correct. And so this time, we're going to be looking at both an area above and below the mean, but this time we're going to be looking for areas beyond the z-scores. And so to answer this question, we have to take 4 and 8 and convert them to z-scores, which we did in previous examples. And then we have to find their corresponding areas, but this time looking at column C, and then we just have to add those together. And so let's start with the raw score 8. We know that the z-score 1.01 corresponds to 8. We previously found the area between the mean and the z-score was 34.38, but this time we need to find the area in column C, the area beyond the z-score. And so when we look at the table, we find that corresponds to an area of 15.62%. Now we have to find the area corresponding to a raw score of 4. Remember that its z-score is negative 0.94. And remember that we found an area between the mean and the z-score of 32.64. So the area beyond the z-score will be in column C. And when we look up that z-score and its corresponding area, we get an area of 17.36%. And when we add those two areas, 15.62 and 17.36, we get a total of 32.98, and that's the answer to the question. So approximately 33% of people got below 4 or above 8 correct words. Note that if we took that area that we just calculated and subtracted it from 1, we would get 67.02, which was the answer to the exercise 3 problem. In our last example, we're going to work backwards, and we're going to try to figure out what the word sum score is for somebody who scored in the 95th percentile. And suppose we also want to know how many words that person got correct. So we start with a diagram. This time, we're looking for the area under the curve corresponding to 95% cumulative distribution. And so we need to find a z-score corresponding to an area under the curve of 0.95. Now remember that half the area under the normal curve is equal to 0.50, and only half the area is shown in the table. So for the moment, we're only going to look at the the area under the curve to the right of the mean, and we're going to ignore the area under the curve to the left of the mean. And so we're going to take our 0.95 and subtract the area to the left of the mean, 0.50, leaving us with 0.45. And then we're going to look up 0.45 in column B, the area between the mean and the z-score, and we're going to figure out what z-score corresponds to that value. So looking at the table, in column B, the closest z-score corresponding to that is 1.65, which has a area between the mean and the z-score of 0.4505. And so z is our closest approximation. So we're going to use 1.65 as our z-score. Now we're going to work backwards. We're going to solve the formula for y, and we're going to fill in the value of our z-score, 1.65, as well as the mean, 5.92, and the standard deviation, 2.05. We start by doing some basic algebra. We're going to multiply each side by the standard deviation. Next, after we've simplified this, we're going to add the mean to both sides. And when we finish our calculations, we find that the score that we're looking for has a value of 9.30. And so we can say that a person in the 95th percentile got over 9 words correct. And that's the answer to this question.